We will be running about linear versus logistical regression, the comparison between hypothesis, parameters, and cost function optimizations. The fundamental difference between linear regression and logistical regression is when in linear regression, used for regression problems, predict a continuous numerical value, example house price, temperature, sales revenue, the output can be from minus infinity to plus infinity. In logistical regression, it is used for classification problems, predict a categorical cost output or probability, example spam versus not spam. The output can be from 0 to 1. Linear regression hypothesis. And the hypothesis aims to fit a straight line or hyperplane through the data points. It calculates the weighted sum of inputs. The output is directly the predicted values. Logistical regression hypothesis. The hypothesis uses the Sigmund function to squash the linear output with a probability between 0 to 1. The output represents P, y is equals to 1 or x, the parameter, the theta, the weight, the bias, and the optimization. We determine the influence of each features. In logistic regression, they control the orientation of the decision boundary. In the bias theta act as an interpreter. It shifts the line linear of the decision boundary logistic without changing its shape or angle. For optimization, in both models, the game is to find the optimal set of thetas that minimizes the error between prediction and actual labels. Cost function linear regression. The mean squared error or MSE. With this formula, it measures the average squared difference between the estimated values and the actual values. The shape is a convex bold shape and optima has a single global minimum. The cost function for logistical regression. It's a log loss or cross entropy. We cannot use MSE because the Sigmund function uses the const function which is wavy, not convexy, causing many local minimas. So by using this formula, log loss penalizes confident wrong predictions heavily, ensuring a convex surface for optimization. The gradient descent, an iterative optimization algorithm used to find the parameter theta that minimizes the const function j of theta. The mechanism is image standing on a hill. The const function calculate the slope at any current position. Take a step in the direction of steepest descent. Repeat until you reaches the valley floor. Minimum cost. Surprisingly, the update rule looks identical for both algorithms, which would be this formula. For linear deviation, here h theta x is the linear function of theta t. Standard deviation for mean squared error. And the logical deviation here would be a h of theta x is the Sigmund function 1 of plus e minus z, which is derived from log loss but results in the same algebraic structure.